Welcome to Session 15, Choosing Displays and Detecting Distortion. An honest display matches the variable type and preserves the true numerical relationship between values. 10 examples choose bar graphs, histograms, rates, and box plots while auditing three-dimensional shapes, pictographs, truncated axes, uneven time gaps, invalid circle totals, missing legends, and accessibility. Match the display to the question, then audit title, axes, units, interval spacing, baseline, legend, and source before trusting the visual impression. Example 1. A hospital wants to compare patient counts across emergency, surgery, pediatrics, and cardiology. Choose a display. The bars make category magnitudes visible on one common scale. Plan. Use separate bars for separate categories. Step 1. Department is categorical. Step 2. The response is a count for each category. Step 3. A bar graph makes department heights easy to compare. Step 4. A histogram is not appropriate because departments are not intervals. Quick check. Bars should share a clear count scale and category labels. This matters in real life because hospitals use category comparisons to allocate staff and beds. Example 2. A factory wants to show the distribution of bolt lengths measured in millimeters. Choose a display. The histogram groups numerical values into adjacent intervals. Plan. Use a distribution display for quantitative continuous measurements. Step 1. Bolt length is quantitative and measured on a numerical scale. Step 2. The goal is to see how values are distributed across ranges. Step 3. A histogram groups lengths into adjacent intervals. Step 4. Therefore, a histogram is appropriate. Quick check. Touching bars reinforce that neighboring bins belong to a continuous scale. This matters in real life because manufacturers inspect measurement distributions to detect process drift. Example 3. A chart shows annual profit with a three-dimensional cylinder whose volume grows with the value. Explain the distortion risk. The comparison places both cases on the same scale. Plan. Identify visual dimensions that change in addition to the intended height. Step 1. The data should control one comparable dimension, usually height or length. Step 2. A 3D cylinder may grow in height, width, and apparent volume. Step 3. The visual size can increase much faster than the actual profit ratio. Step 4. A simple two-dimensional bar chart would support more accurate comparison. Quick check. Decorative volume should not be interpreted as proportional evidence. This matters in real life because financial graphics should prioritize accurate encoding over dramatic decoration. Example 4. A pictograph uses one full car icon for 100 vehicles, but a half icon is drawn half as tall and half as wide. What goes wrong? The comparison places both cases on the same scale. Plan. Compare the intended half value with the icon's changed area. Step 1. A half value symbol should represent 50 vehicles. Step 2. Scaling both height and width by 1/2 reduces area to 1/4. Step 3. The half icon therefore looks like only 1/4 of a full icon. Step 4. Use half of the icon in one dimension or a clear numeric label instead. Quick check. Visual area, not only height, controls how large a symbol appears. This matters in real life because infographics must scale symbols consistently to avoid misleading readers. Example 5. A bar graph compares 48% and 52% but begins at 47%. Explain a more honest design. The bars make category magnitudes visible on one common scale. Plan. Show the real 4-point difference without making the bars appear enormously different. Step 1. The actual difference is 52%, 48% equals 4 percentage points. Step 2. Starting at 47% makes bar heights above the baseline 1 and 5 units. Step 3. A bar graph should generally begin at 0 because bar length encodes magnitude. Step 4. Alternatively, a clearly labeled dot plot can focus on the small difference without deceptive area. Quick check. The design should allow readers to see both the values and their modest difference. This matters in real life because polling graphics should communicate uncertainty and scale rather than dramatize small gaps. Example 6. A line graph connects data from January, February, and June at equal spacing. What correction is needed? The timeline makes unequal time gaps visible. Plan. Make visual horizontal distance match elapsed time. Step 1. January to February spans 1 month. Step 2. February to June spans 4 months. Step 3. Equal spacing falsely suggests equal time intervals. Step 4. Place months at proportional positions or include all monthly positions with missing values indicated. Quick check. The apparent slope should represent change per unit of time. This matters in real life because accurate time spacing matters in sales, medicine, and environmental monitoring. Example 7. A circle graph has slices labeled 35%, 30%, 25%, and 20%. Audit the display. The circle audit checks whether the parts form one complete whole. Plan. Add all part whole percentages and compare with 100%. Step 1. Compute 35 plus 30 plus 25 plus 20 equals 110%. Step 2. Circle representing mutually exclusive parts of one whole must total 100%. Step 3. The labels contain an error or the categories overlap. Step 4. The graph should clarify overlap or correct the percentages. Quick check. A 110% total cannot be partitioned into one non-overlapping circle. This matters in real life because budget and survey charts require a total check before publication. Example 8. A graph reports crime counts for 2 cities of very different population sizes. What additional statistic supports a fairer comparison? The comparison places both cases on the same scale. Plan. Replace raw counts with a common population base. Step 1. A larger city can have more incidents partly because it has more residents. Step 2. Compute a rate such as incidents per 100,000 residents for each city. Step 3. Use incidents divided by population times 100,000. Step 4. Compare the resulting rates while also considering reporting differences. Quick check. A fair comparison uses the same unit and population base for both cities. This matters in real life because public policy comparisons often require per capita rates rather than raw totals. Example 9. A dashboard uses red for small values and green for large values but provides no legend. Identify the communication problem. The comparison places both cases on the same scale. Plan. Check whether every visual encoding can be interpreted independently. Step 1. Color appears to carry meaning in addition to the plotted numbers. Step 2. Without a legend, readers cannot know what red and green represent. Step 3. Color-only meaning may also exclude readers with color vision differences. Step 4. Add labels, a legend, and non-color cues such as symbols or direct values. Quick check. The display should remain understandable in grayscale and with assistive technology where possible. This matters in real life because accessible dashboards help all decision-makers interpret the same evidence. Example 10. A report needs to compare median rent and IQR across 8 neighborhoods. Choose an efficient display. The box plots align median and interquartile range on a common scale. Plan. Select a graph that shows center and central spread for multiple groups compactly. Step 1. Median and IQR are components of a box plot. Step 2. Place the 8 box plots on a common rent scale. Step 3. Compare median lines and box lengths across neighborhoods. Step 4. Side-by-side box plot display is efficient and appropriate. Quick check. All boxes must share the same scale for visual comparison. This matters in real life because housing analysts use box plots to compare typical cost and variability across areas. Session 15 Recap. Categories call for separate bars, distributions call for numerical displays, and every comparison needs a common, clearly labeled scale. Bar length should begin at 0, time spacing must be proportional, circle parts must total one whole, and visual area must not exaggerate the data. Quick check. Which display efficiently compares medians and interquartile ranges across 8 neighborhoods? Use side-by-side box plots on one common rent scale.